Okay, live stream should be running. And welcome to everyone here. Today's our first Q&A session. I thought I'd open with how far you are advanced in your planning for the exam. Because we have the Christmas, the holiday break in between. I guess many of you will properly start after that. We don't have any timetable sessions after Christmas, but we could think about making one in one of the slots in the first week. Not on the Monday because the uni is officially closed still. That would leave us with the Wednesday, so that might be an option. But then some students are not back yet. We'll figure something out on Campus Wire if the desire is high to have another session like this. Let's have the attendance code as well. There you go. And a few of you have been busy posting some questions, so I think we have some material to go through. And I have to not forget that we should stop early to leave time for the end of module survey. I'll comment on that later. So, no polished slides for this. This is all made up on the spot if you want. So I also in the past don't usually put these videos on the proper YouTube, but I keep the recording just as the live stream recording, keep it up there, both for people to look at it again or for people who couldn't be here or couldn't follow live at home. I know of at least one case, and there will be others. But I don't cut this into nice pieces, etc. The quality of these sessions is also maybe not comparable to the other sessions. All right, that's how it is. It's more a bit informal and ad hoc. So as I said, there's some. First of all, is the font too small, or can you still read this properly? Also in the back, this might get a little too small. We don't need to see all the questions on one screen now. That looks weird now. Okay. The latest question is highlighted. Got it. Okay, the popularity vote is there's one question with 1 upvote and all others with 0, so that's not super significant. But let's start with this one still. You can still vote on the others if you want to influence the other part. This will be a quick one. Yes, so you can use both pages, both sides of one page. So I'm talking about one A4 page, front, overleaf. You can write on both. Okay, I thought there was something about lining or so. So use whatever paper you want. I hope this doesn't open any back doors. Like ordinary, like paper. You can have it with graph paper or with lines or with nothing. You can write as small as you want if you feel you can still read it. It must be handwritten. That's the requirement. And it must be a single A4 page. So you don't unfold your poster and have a one page for your 2 neighbors as well. Any other questions or remarks on this? I talked about this before, right? It's mostly a psychological thing. Let's just pick the next one. So I'll read this out. It's a bit small maybe. Are the questions in the mock exam the same as those on the real exam? For example, in the mock exam, we have a question given the 7-bit block B7 up to B1. Okay, the 7 bits received as a 7-4 Hamming code, and so on and so forth. Should I expect this question but with different inputs, or may it not appear at all? Let me answer the first sentence first. I would not put exactly the same questions on the exam as in the mock exam, because that feels like you're just learning by heart the questions from the mock exam. But the same type of questions can appear. And there's also no fixed rule that none of the questions is allowed on the exam in exactly that formulation. It could happen by chance that one of the questions in the exam is very similar to what you've had on the mock exam or even identical. So don't use the mock exam as an exclusion list. Oh, he touched on this in the mock exam. I don't need to learn about it. Don't do that. They can still occur. But of course, the mock exam has only 40% of the questions, so there will be more on the actual exam than on the mock exam. And there's much more material that we covered than the mock exam covered. So obviously, many other questions are possible. Yeah, specifically this question is from this second tier. So I'll, at the danger of repeating myself for the gazillionth time, there will be 3 types of questions on the exam, broad categories. 1 reproduction question, 1 application question, and 1 transfer question. You will have 5 sections, and every section will have mostly 1 of each type in this order: reproduction, application, transfer. And from these 5 sections, which are unfortunately called questions on the exam script. So there's 5 questions with 3 sub-questions, but they're completely independent. Question A, like on the mock exam, is this flickering? Like on the mock exam, which maybe I should open to show you this, maybe more useful. Let's do that here. Took me some effort to make sure I'm not opening the other exam, you know. So that has mock exam fed in the background, so that should be the right one. It's called question 1, and it has 3 sub-questions, A, B, and C. And there will be 5 of these questions, each with 3 types, makes 15 in total. They're called questions because they're marked as 1 unit, and then you get the best 4 out of these 5 questions as your mark. So in a way, you can blow 1 question entirely and it doesn't affect your mark at all. You have 5 chances and you only need to succeed 4 times. But the unit is question, so the 3 parts count together. It doesn't work that you do all the part A's perfectly. That alone doesn't work, right? So you have to add these 2 up, these 3 up. Right, I mean, on this example, the first is a reproduction kind of question, because this is something that in one way or another, I literally said this in class, what the answer is. For the second one, this is run length decoding, or decode the run length encoded bit string. Please read carefully, like on the exam. I've had this in the past that some people did it the other way around. They should run length encode and they did the decoding, or vice versa. That's a really annoying way to lose points, because that's far from the correct answer. So just make sure you read it very slowly. You will have enough time to read the questions. Don't worry about time. All right, so we're run length decoding. Then you do that. You haven't seen exactly this example, but we've done one in class. You may have done one more. You do one in the class test that's up now, and maybe even one more on the tutorials. Don't even remember. But you've done it before with some examples, and so this is a new one. So you apply something you learned. It's not just reproduction. Yeah, maybe I can comment on these these remarks you will see in several questions. Basically, what the question asks for is just the final answer. But you have to be a bit brave to just show the final answer. Because if that's wrong by 1 bit, you'll zero the question. So the safer bet is to give some intermediate steps of how you arrived at the answer. If you make some small silly mistake in the derivation, then the answer might still be wrong if you compare it as exactly equal or not exactly equal. But I will do you the favor of tracing your computation and check if there's just a small little thing that I could identify as, I don't know, for this example, the obvious thing to get wrong is converting from decimal to binary. That's something that that's easy to mess up. And you would just lose 1 or 2 points for something like that, or marks. But if you just give me the final answer and it doesn't match the correct one, you're out of luck, because I can't really see if you just wildly guessed or if you just made one typical mistake. So even though this says the final answer is the important bit, give some intermediate steps. And you'll work it out step by step anyways, unless you're smart super brain. So it's probably not even costing you much more time. You're welcome, if you want to work out the problems on the exam sheet first in a like scrap paper style, and then copy it cleanly on a fresh page. You can just cross out what you don't want marked. That's all right. Again, 2.5 hours is quite a lot of time for these questions. Usually people are done with 1 round of going through it before the time. Again, you can practice this with the mock exam. Time yourself how long you need to do the questions. Even if you have done the same one before, you can still pretend it's new and you have to write down all the steps, so you can measure roughly how long it takes you. And finally, part C is a transfer question, which is something where you just have to know the things we discussed and apply them in a slightly new way. So in this case, for example, it's a certain application scenario that hopefully looks somewhat familiar to some of the things we discussed. And then the task is to match that to the formalizations we had and then the algorithms that we gave for solutions to that. Okay, not sure if I fully addressed the original question with this. So there will be new exam problems apart from the one on the mock exam, but the one on the mock exam are still relevant. Any other clarifications, remarks on this? All right, then let's declare this one done. Okay, next question is, will we need to know how to write pseudocode in the exam? In principle, yes. You should be able to write describe an algorithm, an algorithmic idea that you're asked to have. You don't necessarily need to do this in pseudocode in a specific format. Something like bullet points and very precise English text gets you a long distance. You can also go more precise. If you prefer, you can write a Python program instead, or something that resembles Python very, very closely. As long as I can make out the intention, that's fine. So I'm fine with Python or C, C++, Java. What else? JavaScript a little bit. I don't know. But you probably won't get into the technical details of writing this code where that makes a big difference. Any other remarks on this? The length of the code that you have to write will be quite limited. At most, the length of things that we had on slides. So if it doesn't fit on one slide, it's unlikely to be on the exam, just in terms of the time you need to come up with it. Well, one question one could have is, modify a certain algorithm to something else, to do something slightly different. I don't know, a lovely transfer question could be, here's an algorithm that we had in class, but there's something changed. Does it still work? Or explain why this is broken. Stuff like this are nice questions because you can create many varieties of these. And I think it's a fair test of checking whether you grasped the essence that makes the algorithm work. Okay, that goes beyond this question a bit, maybe. Other remarks on this one? Okay, the next question is, what are the pass marks for the exams? And how many marks should we get in the handwritten exams? So first of all, there's only one handwritten exam, or the exam is handwritten, right? Just in case that wasn't clear. Not sure if the formulation was getting at this. The pass mark for you is 50. At postgraduate level, 50 is the pass mark, whereas undergraduate is 40 marks. You're doing don't ask me why. I mean, not sure if this makes a ton of sense, but that's what it is. Also, UK marks, anything above 80 is very exceptional. So if you're in the 70s, you get a distinction mark, a distinction grade overall. Nobody really expects the standard student to be above 80. It's very exceptional cases. So the same is true for the exams. So they're designed so that it's really hard to get full marks of the entire thing. But that said, it has happened. Like it's not so impossible, right? If you can't leave many points on the way with silly mistakes, but it's quite doable, I think. I explained the rules with best 4 out of 5. What you see on the mock exam, we just go back to that briefly. This is actual marks in terms of the final mark. Question 1 adds up to 25, as do all the other questions. If you take 4 times 25, that's 100. So that's by choice. Shows you directly how much each question is worth. Yeah. It roughly reflects my belief that the reproduction questions are a little less interesting than the others. That's why these have 5 and the others have 10. But how you earn your marks is irrelevant as long as it adds up to more than 50. Okay, the other part of this question, it's theoretically possible, even though because the exam is 60% not super likely, that you get something slightly below 50 on the exam, but you overall have an average for the module that's above 50. My understanding is you still have to pass the exam as in isolation. So the exam needs to be above 50. It's not enough if the module mark is above 50. Maybe don't quote me on this. I think I just never had a case where this rule was relevant. What happens if you don't pass the exam is that there's a resit opportunity in August, together with the resits from the second semester. And there you can try a second time. Yeah, so aim for at least 50 marks. Haha, well, of course you do. I think it doesn't affect your preparation much. It's not like you aim for just passing and not doing better. So I'm not sure if I can give you useful, actionable advice on this, apart from prepare yourself well. Questions on the mark computation and so on? The percentages, etc., for the continuous assessments, they were in Unit 0 on some slide, if you want to revisit that. So you will also get the class tests play into this, and the continuous assessments, like the second one that's still ongoing, and then we'll have a slight bit is the participation mark from Slido, and you get a little bonus on the class test mark for all your active participation on Campus Wire. Another question, do you have any extra reading that might be useful to build skills for the third type of question, the transfer questions? In a way, the question is making me smile a bit, because to build the skills, you probably want to practice problems and not passively read. So each unit page has this list of further reading at the bottom of or sources further reading, with some standard textbooks that cover a part of this. There's no textbook that nicely covers all the topics, but there's every topic covered by some nice textbook. So you have to find the appropriate places potentially. What most textbooks do is have a list of exercise problems. And these are often at the level of application and transfer questions. And the other thing mentioned many times, there's the tutorial 10, which has an additional set of transfer problems. Because I think the reproduction questions are relatively clear what they will look like. You just go through all the material we covered, and then you basically can ask a question about each point. So that's not so surprising, or not so hard for you to come up with questions on your own. And the same for the application questions. We have all the class tests, which give you some examples. That's exactly the type of application questions. So again, you can easily make your own. Take some algorithm we covered, apply it on an example input, and see if you can follow through and compute the result. The transfer questions are a little harder to come up with. And the problem is that many interesting puzzles are just too hard and time consuming for an exam setting. For example, both the Bamboo problem and this exam cheat code, they would take too much time on the exam to really give you a fair chance to come up with that. So these are not super suitable. The transfer questions have to strike this delicate balance between going beyond what we've done, but also being very limited in the amount of time you need. Even if you have very well prepared, there are questions out there that will still take you time. So these wouldn't be fair on an exam. What you can do is look at the resources that are mentioned on the unit pages. Many of them have exercise problems listed. And if you work on those, you will definitely learn something. If you're unsure if these are realistic for an exam, you can post them on Campus Wire. I think that's useful for two purposes. Other people can see if that question is useful for them, and I can give a comment saying like, okay, great question, but this takes way too long, or yep, that's realistic. Other comments on this one? Okay, the next question asks about a cheat sheet for asymptotic notation. There are some of these online. Okay, many sources online use a slightly different definition. Maybe this is something that we could just have a look at now. So there's some basic things on the slides. There's a slide called Frequently Used Facts about Asymptotics in Unit 1. So that's things like C times if c times a function, then that's the same as same theta class as the function alone, whenever that is not 0. And it lists a few other things. The other part is on the tutorial. There's a question about ordering some functions that I would call, most of them are somewhat like a standard scale. So you have n to a certain power, you have log n, or several logs nested, logs with different bases, exponential functions, a constant to the n. You should know how these relate asymptotically, because that's something that saves you a lot of time. You can always go by definition, and I gave you the definition that 1 doesn't have any weird mathematical glitches if you look at it in detail, and b is easy to execute, because all you need to do to prove that some function is big O of another function, say, is take the quotient of the functions and check what happens if n becomes big. This is super easy if you have Wolfram Alpha at your disposal, which on the exam you will not have. So practice a few tricks to compute limits. So you're studying limits of this type. And the standard tricks of the trade are either you know for a few standard scale questions what the answer is right away, or you use L'Hopital's rule. That's usually what you have to do. So very often we have this infinity divided by infinity case. Both the numerator and the denominator go to infinity when n becomes big, but they might do so at different speed. And so then L'Hopital's rule helps you. What that says is take the derivative of the numerator and the derivative of the denominator, and then the limit is the same. And you have to apply that rule often several times before you get something that you can decide. A classic example is something like log n divided by n squared. Now you can either know, oh, log n grows slower than any polynomial, so it's going to go to 0. Or you say that's of my infinity divided by infinity type. So I use L'Hopital's rule. So the limit remains the same when I take derivatives of both. Let's pretend that this is the natural log. So then the derivative is just 1 over n. The derivative of this is 2n. And now you can already see, like, this is okay, should copy the limit. Now we have a limit where numerator is constant, denominator goes to infinity, so the whole thing goes to 0. So often you can apply L'Hopital 1 or 2 times, and then you see the pattern. You don't have to execute it all the way down. Yeah, there's not too many examples where this doesn't work. I don't think there's any that's relevant for us. The only other tricky bit is something like sine or other functions that have oscillatory behavior. But they're just these few trigonometric functions that are relevant for us. So you can just remember that, well, these are bounded, and then usually that's enough to decide what's going on. There is one very nice thing. Let me maybe show you that. But this is like, I didn't point this out because it goes way too far, and doesn't use our definition maybe. There's the theoretical computer science cheat sheet. Has anyone heard about this or stumbled upon it? Let's see if that's still easy to Google. Does that show now? Yep. So this contains a lot more. This contains a lot more things, lots of formulas that we're not necessarily using, and it has this other definition of big O. They're essentially equivalent, but you don't need to use them. There's a lot of formulas that are about discrete math. I think there's also a bit about limits. There's some well-known derivatives. Not much about limits, right? Yeah, I think this is not too relevant for us. Most of it goes into different directions, and not too many of these simple rules. So I would say check that you know the standard scale that was on the tutorial sheets. That often is enough. Plus the little rules how to compute with big O terms. So the sum of two functions, what does that mean for the theta class? The product of two functions, a function times a constant. It's just a handful of things, really. Plus, have a basic command of computing limits of this type for the cases where you're unsure. And keep in mind that there's a few extra cases, like having sine functions, trigonometric functions involved. But often they can just be replaced by being between two constants. I think that's all I can think of. So all the type of questions that would come up on an exam are similar to the asymptotic questions that we had in this one class test. So that's the type of detail you would be required to do. In particular, I don't ask for a proof that a certain asymptotic relation is true. I would only ask for which is the correspondence or the relation between two functions. Is this one big O of this one, something like this? I wouldn't ask for proofs because, again, it's not an analysis class, so we don't need to test you on that. Okay. I think we have question for one or so more slides, and we should move over to the end of module survey, and we can do another round in January, but I'll have to check what date is available. I don't publish a written sample solution of the mock exam like you've seen for some of the tutorials, but you can I guess you can post something on CampusWire with a clear spoiler alert that you're attempting to solve one of the mock exam solutions. And maybe there will be some comments on that. Any other question that you're burning hard to do now as opposed to the uni is officially closed over Christmas. I'll be away a few days after Christmas, but then it's not impossible that I might peek into CampusWire once in a while and do like the short questions. Sometimes it's quicker to do them while you see them as opposed to collecting them and then have a longer session. So I make no promises, but I'll try to timely do things where I think it's helpful to be quick. And same for you, of course. I mean, you're not required to work over Christmas, but realistically, you may want to use the time, so you can do that. That's an important one. So the mock exam is on CampusWire. It's a little, there's no convenient place to put just files, but it's linked from one of the posts. So there's a pinned post, should appear in the top section about the exam setup, and that's where it's linked. Okay, we've covered that already. It's two-sided, A4 page. That one's also easy. The bonus mark for CampusWire is collaboratively. You all earn on the same account, so it doesn't matter if it's anonymous. One of the reasons why I did that. All right. This is about the exam cheat puzzle, I guess. I guess my suggestion is to look through impossibility results that we did in the units 7 and 8. Maybe there's something like that is helpful. Okay, this one, maybe I can do this one very briefly. In principle, you may be asked to do small proofs on the exam, especially in the transfer problems. They won't be massive proofs, again, because of time constraints. But a typical transfer problem could be, here's a problem that's related to an algorithmic problem we talked about in detail. Describe an algorithm and argue why it's correct. Something like this. So if it says argue that it's correct, this is not a very, very formal proof in all details, but it should resemble something like a proof. You can't just wave your hands and write 300 words of a convincing essay. It should have some precise language in it, but maybe you can compress it a bit. Some of the tutorial problems would be too long to do on an exam. I'm not sure if you're thinking of something specific there, but yeah. I guess that's about running time, etc., in terms of Big O and so on. There's bookwork questions, which, as you've seen in the mock exam, tend to ask stuff like this. So if you can't be bothered to learn this by heart, that sounds like something to go on your cheat sheet, right? Okay, I think now let me stop with questions so that we have some time for the end of module survey. What I'll do is I'll send you a reminder or something like that. So if you've already filled it out, you will not receive another email. If you haven't submitted it, you will get some reminder email with the link in it, in case you lost that one. Okay, well I'll try to do that on the slow network. The end of module survey is very impactful for improving the module itself, for evaluating teachers, and for getting a feeling for what students want changed in the future. The nature of the thing is, it doesn't help you for this module anymore, obviously, because it's end of module survey. The results are completely anonymous. You don't have to fill them out, but I would ask you to, because the results are devalued if the response rate is 5%. Then the 5% who bothered to write up some very helpful comments might get their feedback mostly ignored because people say, it's just 5%, that's not representative. So there's often the push is to fill out the survey and of course be honest and fair. If you have good comments, then use the free text comments. These are the most useful. If you don't have very concrete suggestions, it's fine. You need to leave them blank as well. But try to fill out the rest of the survey so that the collective feedback gains weight. We've had our website restructured. Now I don't find things anymore. Okay, almost there. Yeah, and as I said, the surveys are definitely looked at, and both Ben and I will be evaluated in some sense on it. It's not like we have to pass some specific mark, but people look at it. Come on, log in. All right. You should now get this email reminder if you haven't found the link. Does anyone have trouble finding the survey? Let me know if so. Okay, I think I'll close the live stream. So we'll fill out the survey. Then I'll wish you goodbye till Wednesday. And I'll check. So probably the Wednesday in the first week of January could be another Q&A session.